we are going to take the definition of effort arm and resistant arm. Effort arm, it is the distance between the fulcrum and the effort force, or the effort force. Yes. So this distance, it is called the effort arm, and the distance between the resistance force and the fulcrum is called the resistance arm. Okay. And here is telling me that law of levers equal the force of its arm times the resistance times its arm. Okay, so in case of the force, the force, it means the effort force equal to the resistance force, so the arm of force equal the arm of resistance. Okay, in this case we are going to find that they are equal to each other, so it does not conserve effort, mean does not save any effort. Okay, this is the force is 16 and this is the resistance is 120, so the resistant force is more than the force, and the arm force equal 13, and the arm of resistance is 15, so the arm force is longer than the resistance force, so the resistant force will be bigger than the effort force, so it will it also be equal, but it will conserve effort. This one, this is the force, and this is the resistant force. In this case, the arm of force is shorter than the arm of resistance, so it does not conserve effort. Why? Because the force of resistance is smaller than the force of effort. Okay, the second one also they have the same, does not conserve any effort. So the law, the force times its arm, and the resistance times its arm also. Okay, so let's continue. So we have notes here that when the force arm and resistance arm are equal, so the force and the resistance are equal. If the force arm is longer than the resistance arm, so the force is smaller than the resistance and the lever conserve effort. If the force arm is shorter than the resistance arm, so the lever does not conserve effort. Here it is the problems. It came something is missed. So in the first one, we can find the missed is the resistant arm. So how we can find it? We can apply the law, force times its arm equal resistance times its arm. So how we can find the resistance arm? By multiply 2 times 5 divided by 1 equal 10, and also resistance equal 3 times 10 divided by 10 equal 3. What is the unit for the force is Newton, and what is the unit for the resistance, the force arm or resistance arm, equal centimeter. Okay, in the second example here, it giving me the weight or the load, and I want to find and also is giving me the amount of the weight you want to equilibrate this weight, and also I want to know what is the positions we are going to put this weight. Determine by drawing the position of where one weight is placed for the levers to regain its balance. To regain or to balance it, it means to it is the effort force. يبقى resistance, it is the load, and exerted by the person to equilibrate, it is the effort force. Okay, and the distance between two opening is equal 1 centimeter. Okay, here in the first one, on the first image on the left, we can find that resistance force equal 1, distance equal 2 because we have 3 opening, and the load, the effort force equal 1, so we can find the distance by times 1 times 2 divided by 1, so equal 2 centimeter. Okay, so we are going to put the load here. We can put the load after 2 points, we can put it here, it is the 1 Newton. Okay, the second one, so here is the load equal 1 times 2 equal force arm. We can name it A times 1, so A equal 2 centimeters, so it will put in after 2 opening. And here we have the load is equal to, so resistance force equal to, after 2 points it's equal to, and the arm is equal A, or the force arm is equal A, and the load is equal 1, so A equal 4. So the force arm equal 4 centimeters, so each one, the distance between two opening is equal 1, so we are going to put it 1, 2, 3, 4 after 4 opening, so we are going to putting the load after 4 opening. Okay, so the first class lever, when it conserve effort and when it does not conserve effort. We have 3 possibility. When the force arm equal resistance arm, okay, they are equal. When the force arm is longer than the resistance arm, when the force arm is shorter than resistance arm, in which case it will conserve effort when the force arm is longer than the resistance arm. In this case it will conserve effort. So the other cases it will not conserve effort. When the force arm equal resistance arm, or when the force arm is shorter than the resistance arm, so it does not conserve any effort. Second class lever, they are conserving effort. Why? Because in all cases the resistance, so if we can draw anything in the second class levers, like the nutcracker, so this is the image of nutcracker, so we are going to put the nutcracker here. Okay, so this is, we said this is the fulcrum, and this is the resistance force, and this is the effort force. So the distance between effort force and the fulcrum, this is the force arm, and this is the resistance arm. So the and here the force arm is longer than resistance arm, so the effort force is less than resistance force, so it conserve effort. Okay, we have example for a third class lever, like the manual probe. Here we have, this is the fulcrum, and this is the effort force, and this is the resistance force. So this distance, it is the resistance force arm, and this is the force arm, so it has a long distance, so the force arm is less than resistance arm, so it does not conserve effort. Why? Because the force arm is shorter than resistance arm, so the resistance force is less than effort force, so it does not conserve any effort. Okay, so the second class lever is always conserving effort, and also sometimes the first class lever conserve effort when the force arm is longer than the resistance arm, so the effort force is less than, the effort force is more than the effort force. Okay, so some machines does not conserve effort, but they are using in other things. It has the other benefits, like increasing distance, in, like in the manual probe, increasing speed, like in the hockey pad, and also performs accuracy in the tweezers. That is the end of the lesson. So we have talking about who or which levers conserve effort, and then we said that when the levers conserve effort, means that the force arm is longer than effort arm, so the resistance force is longer than effort force, so it conserve effort, like in the second class lever and sometimes in the first class lever. But then third class lever and the other cases in the first class lever does not conserve any effort. Thank you for watching our lesson.